This is our first lesson in Unit 1213, which is all about right-angled trigonometry. So in section A here, we're just going to review some stuff about right-angled triangles that you would have learned in previous courses. So we're going to be able to, we want you to be able to label the sides of a triangle with the appropriate letter and solve for the lengths of unknown sides in a right triangle using the Pythagorean theorem. And then we're going to list, sort of introduce a couple of concepts that are going to be really important as we work our way through this unit. We're going to want to be able to identify the hypotenuse, the adjacent, and the opposite sides in a right triangle. And we want to be able to determine the values of the sine, cosine, and tangent ratios for a right triangle using a calculator. So calculator skills are going to be really essential for this unit. So even if you're just watching this lesson, make sure you've got your calculator with you. The other thing that you're probably going to want to have is your formula sheet, because your formula sheet is going to list some information about the sine, cosine, and tangent ratios that we're going to introduce a little bit today, but really focus on in later lessons. So let's just start off with a simple right angle triangle here. Typically, when we have a triangle, we are going to label the vertices with capital letters, X, capital Y, and capital Z, and then we label the lengths of the sides with small letters. So I'm going to label the side that is across from capital X as side X. So side X has a length of 4 centimeters. And then the side that is across from angle Y is going to be side Y, small letter Y. And the side that is across from angle Z is going to be small letter Z, which is going to be 7 centimeters. In a right angle triangle, there's one side that you learned last year is the most important, and that is the hypotenuse. And the hypotenuse is always the side that is across from the right angle. I'll just put the little symbol for the right angle in there. So in this triangle here, if we go across from the right angle, this side over here, side Y, is going to be our hypotenuse. And the hypotenuse is also the longest side in our triangle. And what you learned last year was how to use the Pythagorean theorem to solve for the length of a side in the triangle. Let's switch colors here to, I don't know, Pythagorean theorem. Okay? And the way the Pythagorean theorem works is it relies on knowing which side is our hypotenuse. In the Pythagorean theorem, that hypotenuse, and I'll just use HYP for hypotenuse, the square of the hypotenuse squared is equal to the sum of the other two sides So we'll have the other side and the other side, and both of these are squared. So you take the other two sides, square them, add them together, that gives you the length of the hypotenuse squared. So if we're applying this to the triangle that we have here, our hypotenuse is side y, so y squared is going to equal, our other two sides are x and z, so x squared plus z squared. So in this case, if we wanted to solve for the length of side y here, we would just sub in our values for x. Let's see, x is 4 centimeters, so that's 4 squared. Z is 7 centimeters, so that's going to be 7 squared. And then we can just evaluate. 4 squared is 16, 7 squared is 49. And we add 16 and 49, and we get 65. And we know that the last step here is we have to take the square root. So y is going to be the square root of 65, which is approximately equal to 8.06 centimeters. All right. So let's apply the same sort of thing to a second triangle here. Here we've got triangle IJK. So let's start off by labeling the sides. The side across from K is going to be side K. The side across from side angle I is going to be side I. And side J is going to be the one that is across from angle J. And our hypotenuse is going to be across from the right angle. So our hypotenuse is this side over here. side k. Our Pythagorean theorem is going to be that our hypotenuse squared, so k squared, is I squared plus j squared. And the one that we don't know here is we don't know what side I is. So that's the one that we're going to be wanting to solve for. So we can sub in our values for I, j, and k. K is 17, so 17 squared. I squared, well, that's the one that we don't know, so we'll just leave it as I squared. And j is 15 plus 15 squared. Now, if we're solving for I here, we want to rearrange this. So we're going to want to subtract 15 squared from both sides. So we'll have 17 squared minus 15 squared equals I squared. And now we can start to evaluate. 17 squared minus 15 squared is going to be 64. So I is going to be the square root of 64. I is equal to 8. And we don't have any units here, so we'll just leave it as I is equal to 8. So you did that last year or grade 8 or grade 7. Now, we want to go a little bit further this year, besides just being able to identify the hypotenuse. There are actually 3 names for the 3 sides that we want to be able to apply anytime we see a right angle triangle. So we want to be able to find the hypotenuse, which is, again, across from the right angle. So in this triangle over here on the left, obviously, this is going to be our hypotenuse right over here. The other two sides are called the opposite and the adjacent. And we label these based on an angle in the triangle, not the right angle, but some other angle. So the other angle in this triangle that we're given is this 30 degrees right down here. Our opposite side is across from this angle, whatever this angle is. So if we take that 30 degrees, we go across the triangle, so the opposite side, that is going to be the opposite side. And the adjacent, obviously, is the third side, but it is the one that is going to be next to that angle that we're interested in. So that's going to be right down here. So the angle is 30 degrees. We want the one that is like right next to it. Okay, so the angle that we're interested in is always going to be in between the hypotenuse and one of the other sides. The other side that is not the hypotenuse is going to be the adjacent, and the opposite is always on the far side. So we can do the same kind of thing with this triangle over here on the right. If we are given this angle J here, 62 degrees, we know that this is going to be our hypotenuse. And we always do the hypotenuse first. It's across from the right angle. Again, if we've got this angle here, we want to go to the opposite side to figure out which side here is the opposite. And then the side that is right next to it is going to be the adjacent side. And we're going to be we want to be able to label those 3 sides on all of the triangles that all the right angle triangles that we encounter in this unit. So because the Pythagorean theorem, as we've just seen, relates the lengths of the 3 sides in a right triangle. There are 3 other relationships that we can apply to right angle triangle. And all of these relationships are between an angle and 2 of the sides. So there's what is called the sine ratio, where the sine of that angle that we're interested in is equal to the length of the opposite side divided by the length of the hypotenuse. There's the cosine ratio, where the cosine of that angle is equal to the length of the adjacent side divided by the length of the hypotenuse. And then there's the tangent ratio, where the tan of that angle that we're interested in the triangle is the length of the opposite side divided by the length of the adjacent side. And of course, these are all ratios because, as we can see, we are calculating a ratio of 2 sides. Ratio of 2 sides, or the lengths of 2 sides. Right? each one of these. Okay, so these relationships are listed on your formula sheet. So you're going to want to have your formula sheet with you while we're working with these. And the sine, cos, and tan are buttons on your calculator that you're going to want to be able to find. So what we're going to kind of do in the rest of this lesson is just make sure we can find those buttons on our calculator and we can work with them. Okay, so here's a little activity we're going to walk through. We've got two triangles here, triangle ABC and triangle DEF. We are going to want to label the hypotenuse, the opposite and adjacent sides using these angles A and D that we've been given here. So this is angle A and angle D. Okay, and then we're going to want to do some calculations involving the sine and cosine and tangent ratios. Before we do any of that, let's label our hypotenuse. I'll start with triangle ABC. So our hypotenuse is going to be over here. If the angle that we're interested in is angle A, if we come across, this is going to be our opposite side down here. And the side that is next to it is going to be the adjacent side over here. So the angle A that we're working with is 36.9 degrees. If on our calculator we find the sine button and we do sine of 36.9 degrees and we hit equals, you should be getting 0.60. Okay. Now, in our triangle, if we take the length of the opposite side, which is 6, and we divide it by the length of the hypotenuse, 10, we get 0.6, which is the same as the sine of the angle. So we can do sine of our angle is equal to opposite over hypotenuse, just like we said on the previous slide. Now, if we have this ratio here, 0.6, we can take it, and on our calculator, there's the inverse sine button, or usually you have to do like second function or shift, and then press the sine button again. If you do that and then put in that ratio, 0.6, so sine inverse of 0.6, and you hit equals, you should get 36.9 degrees. So we can go from the angle. If we start from the angle, we can use the sine to figure out what the ratio is. And if we have the ratio, we can work backwards and figure out what the angle is using the inverse sine. Okay. We can do the same kind of thing for this cosine. So if we hit the cosine, we put in 36.9 and then hit the cosine, we find that we get 0.80. Cosine is defined as adjacent over hypotenuse. Our adjacent side is 8. Our hypotenuse is 10, so 0.8. And if we do the inverse cosine of that 0.8, again, we'll get our 36.9 degrees back out again. Similarly for tan, if we put tan 36.9 degrees into our calculator, we get 0.75. If we take our opposite side, which is 6, and we divide it by the adjacent side, which is 8, again, 0.75. So that ratio tan A, tan of an angle, is equal to opposite over adjacent. And you should be able to do the inverse tangent of 0.75 and get 36.9 degrees back again. So you want to make sure you're able to use your calculator to do these things, because starting in the next lesson, we're going to be using these calculations a whole lot. So let's do the same thing for our other triangle here. We've got angle D up there at the top. We want to figure out, this is our hypotenuse here. We are going to have our opposite, which is across from angle D. So this is our opposite. And obviously our adjacent is right next to it. All right, so the angle D is the same as angle A. So we expect when we put 36.9 degrees into our calculator, of course, we're going to get the same thing here for sine D. Now, the lengths of the sides are different, though. Opposite is now 18. Our hypotenuse is now 30. But when we do that division, we get the exact same ratio. Okay, so the ratio doesn't matter in terms of the lengths of the sides. It's entirely dependent on what this angle is. Okay, if this angle is the same, that ratio of the sides is going to be the same, even if the sides are separate lengths, or different lengths. And of course, we can get our angle back by doing the inverse sine. Cosine, the ratio is going to be the same as it was for angle A, 0.8. And again, even though the sides are longer, okay, they're going to be in the same ratio. Okay, and we expect them to be in the same ratio because, again, these are similar triangles that we're working with here, right? All three angles are the same. So if all three angles are the same, we expect the sides to be proportional. So the ratio between the sides is going to be the same. 36.9. And this is going to be true no matter which of these ratios that we use. We're going to get 0.75 here. We're going to have 18 over 24. Again, 0.75. And we can get our angle back again. Okay. So what do you need to be able to do at this point? If I give you an angle of 27 degrees, you need to be able to, using your calculator, figure out what the sine ratio of that angle is. I.e., you need to be able to do sine 27 in your calculator and get the correct answer. 0.45 and then 99. Okay? We want to be using 4 decimal places for these ratios. If I give you that cos of A equals 0.6428, i.e. I'm giving you the value of the ratio, you want to be able to find what A has to be. So in this case, we're going to be doing the inverse on this ratio here. Okay. So again, we're just punching this into our calculator. A is going to be cos inverse of 0.6428. You should get something that is approximately 50. I think you get 49.999 or something like that. Okay. And if you're given a triangle, you need to be able to figure out in this triangle which side is our hypotenuse, which side is our opposite. Okay, because they've given us this angle theta here, so we want to do this relative to that angle theta. And which side is our adjacent. Then if we're looking to find tan theta, we can look on our formula sheet and we know that tan theta is opposite over adjacent. So tan theta has to be, what is our opposite side? It is 8. What is our adjacent side? It is 15. So tan theta, 8 divided by 15, 0.5333. Again, 4 decimal places in that ratio for accuracy.